Okay, so there is part 2. We are now going to do the drawing for like in part 2. I've already done for 2 examples, so you practice by yourself. So now we're going to do this question. Let's say 3/4 z plus 7 equals to 15. Okay. So then what do we do? We can do so many ways. All right, so first draw your bridge. Okay, then you can divide both sides. You can divide both sides by 3/4. Remember lesson 1 or lesson 2 in term 1. We did complex fractions, remember? So you cross out this 3/4 and this 3/4. And you're left with z plus 7 equals to 15 and 3/4. So let's see. 15 3/4. You put it like that in the calculator and you press equal. You get 20. Okay? And then you continue. You do subtraction property of equality. -7 minus 7. Additive inverse goes away. Z equals to 13. So this is one way. Algebraically, one way. Algebraically. This is way 1. Now we do it algebraically, way 2. We have 3 ways we can do. So algebraically, way 2. 3/4 or 3/4 z plus 7 equals 15. The bridge is important. Remember in lesson 6 or 7 on that side, we use multiplicative inverse. So you multiply with the multiplicative inverse on both sides. This goes away because a number multiplied by its multiplicative inverse gives you 1. So you're left with z plus 7 equals 20. Anyway, this will be 3 goes here once, 3 goes here 5. 5 times 4 is 20. Okay? Then you minus 7 on both sides. Z equals to 13. I will do the check only one time because I'm showing you ways of you doing the same thing. So this is method 2. Okay? Method 2. We did method 1 here. We did method 2 here. We're going to do method 3 here. Method 3, which will do distributive property. So the question is 3/4 z plus 7 equals to 15. So I will multiply 3/4 with z and 3/4 with 7. So 3/4 times z plus 3/4 times 7 equals to 15. Okay? So this is 3/4 z plus 21/4 equals to 15. And then I will subtract 21 over 4 from both sides. Additive inverse makes this 0. Then you have 3 over 4z equals, then you put in your calculator, 15 minus 21 over 4. And you get 39 over 4, okay? And then you do multiplicative inverse. So 4 over 3, 4 over 3. This becomes 1 because a number multiplied by its multiplicative inverse is 1. And then this 4 crosses with this 4 because 4 divided 4 is 1. And 3 goes here once and 3 goes here 13 times. Or just put it like this in the calculator, you should get 13. So Z equals 13. I did it here, I got it here, and I got it here. So you choose whichever method is easier for you. You make the decision. I have shown you 3 different ways. You decide whether you want to do method 3 or method 2 or method 1. As long as your work is mathematically correct, I have no problem what method you choose. Now, let us do the check. I will do the check here. So we have found that Z is 13. So 3 over 4, 13 plus 7 equals 15. Because this was Z. Z plus 7, like that. All right. 3 over 4, 20. 3 over 4 multiplied 20 equals 15. 60 over 4, because remember when we learned in term 1 how to multiply fractions, put 1 here. 3 times 20 is 60, 4 times 1 is 4, equals 15. 60 divided 4 should give you 15. You should check. 60 divide 4. See? But you should know your times table without the calculator. And that's your answer. So when you have a fraction as your coefficient, either divide both sides with a fraction, we do complex fraction, or use multiplicative inverse. So this method is multiplicative inverse. Multiplicative inverse for method 2. Method 3 is distributive property. Distributive property. Okay? Property. Like that. Okay? Alright. One more where our coefficient is a decimal. So, can we do 5/10 equals to P minus 4 equals to negative 70. Alright. So, bridge, divide both sides with 5/10. This 5/10 and this 5/10 goes away. P minus 4 equals negative 70 divide 5/10 equal negative 140. Then additive property of equality, addition property of equality, because here we are minusing, so we'll add both sides with 4. This becomes 0 because of additive inverse. You're left with P. Negative 140 plus 4, that will be negative 136. And this is your solution. And then let's do the one with distributive property. We do method 2. So you have 5/10 P minus 4 equals to negative 70. There you put your bridge, multiply. Okay, so you have 5/10 P minus 2. Well, let me show you. 0.5 times 4. So 5/10 P minus 2 equals negative 70. This here gives you 2. And then you bring down. Then what you do on both sides, you do addition property of equality. Add 2, add 2. This goes away because of additive inverse. Negative 70 plus 2, that will be negative 68. And then you divide both sides by 5/10. 5/10. This goes away. And then you do over here, negative 68 negative 136, which is there. See? It matches that one. So P equals negative 136. All right, let's do a third way. Okay. So you have, and I told you don't have to know all ways. You just choose whichever one you want. Put your bridge. I can write this as a fraction. 5/10 P minus 4 equals negative 70. And then I can do multiplicative inverse. 10/5. 10/5. Remember, this is 5/10, so 5 out of 10. I told you have to know how to read, write decimals into fractions like that. We learned in term 1. So you have to remember, a number multiplied by its multiplicative inverse gives me 1. P minus 4 equals negative 700/5. Okay? Then I can simplify negative 700/5. Negative 700 out of 5. That gives me negative 140. So P minus 4 equals to negative 140. Do addition property of equality. Additive inverse makes that 0. And P equals to negative 136. So I've shown you 3 different ways of you doing it. Now let's check. So you have 5/10 p minus 4 equals to negative 70. And then negative 136 minus 4 equals to negative 70. Negative 140 equals to negative 70. Negative 70 equals to negative 70. Check. How do I know? No, this is supposed to be negative. And there, negative 70. Okay? So I have shown you different ways of you doing. You choose your own method. And remember, say to yourself which property you're using. Multiplicative inverse, addition property of equality. You have to remember that. A negative divided by a positive is a negative. A negative multiplied by a positive is a negative. Remember, this is a fraction because you have to put 1 here. All these things we learned in term 1, you're supposed to be able to apply in term 2 to be successful. Okay?